What would the next interstellar project be after the quiet end of Breakthrough Starshot? Can planets exist around black holes? Why don't all stars combine into one megastar? And in Q&A Plus, are ion engines the future of space travel? All this and more in this question show. It's time for the question show. Your questions, my answers, as always, wherever you are across my channel. If a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. Blue water. When stars form a cosmic nursery, why do they not all gravitate towards each other and combine? Well, the question you're asking is not necessarily about the cosmic nursery. The question you're really asking, when you think about it, is like, why doesn't everything just combine? Like, why do all the planets go around the sun? Why don't they all just get sucked into the sun and combine into, well, it'll still be the sun with a few planets inside of it? Why don't all the stars in the entire Milky Way get sucked into the supermassive black hole at the heart of the galaxy? So yeah, when you start out with a stellar nebula, right, you've got this huge cloud of gas and dust, and it is turning in some rate. And then pieces of it start to collapse. And as the pieces start to collapse, it spins up and pieces will kind of tear themselves off from each other. And then those pieces will start to sort of compress down and you'll end up with what will turn into a star system. And the same thing that's going on here in the solar system is the same thing that's going on with these stellar nebulae, which is that they have a orbital velocity around each other. And so here in the solar system, the Earth is going at 30 kilometers per second in orbit around the sun. It's being pulled in by the sun, and yet its orbital motion is giving an outward force that are in perfect balance, and that leaves the Earth in orbit. The only way to get the Earth to fall into the sun is to cancel the Earth's orbital velocity. And so the same thing, if you've got a bunch of stars that are moving in some kind of interactive way, the only way to get them to actually come together is that you've got to cancel out that velocity. Otherwise, they're going to go into binary stars or sort of larger, more complicated operations. There's systems that have 8 stars in them. And the amount of energy that it would take to make those stars come together and smush into one is enormous. And so what sort of defines how many stars you have in that stellar nursery is just how much overall angular momentum is in all of the particles within the cloud and how it tears itself and breaks itself up into pieces and how those pieces are able to orbit around each other and interact in the larger nursery. But it's a very chaotic environment. And so you will get these stars that will be pushed into binary star systems with each other, or ones that will be kicked out. In fact, over time, every single star within the stellar nursery is getting kicked out into the larger Milky Way one by one. And over a few 100 million years, the entire star cluster is dissipated into the larger Milky Way. SUPAXE Andrew Kirkpatrick. Can a black hole have a planetary system where the planets are far enough away from its gravitational pull that they are able to orbit the black hole safely, including stars and such? Yeah, absolutely. If you replaced the sun with a black hole with exactly the same mass as the sun, then the planets would just continue to orbit around this black hole sun for the same amount of time. Probably longer, because now the black hole isn't going to go through the end of the star the way that the sun will. So you could have the planets going around the black hole sun for billions and billions and trillions of years. As long as nothing came through to disturb the system, it would last forever. And so theoretically, there are black holes out there where the planets are far enough away that they're in a planetary system around the black hole. Now, it's not a great place to be because you're not getting any radiation from your star, but you're at least stable. People have proposed that this is a really good way to organize a solar system, that, you put a supermassive black hole at the heart of your system, and then you bring in stars and you put them in orbit around the black hole in a way that is stable. And then you could put planets around those stars, moons around those planets, and you could have systems that have multiple black holes, multiple supermassive black holes. You could have thousands of stars with 10,000 planets all in one big elaborate system, theoretically. So a black hole is not like a vacuum cleaner. It is just a thing with mass, like anything. It's only when you get really, really close to a black hole do things get weird. Do you experience the time dilation? Do you experience the extreme tidal forces? But once you're far enough away from it, still trapped in its gravity, everything is fine. CK Coffee. Don't know if you mentioned the Breakthrough Starshot project today, but I was so sad to hear that it was quietly shelved. What's our next chance for such an interstellar journey? So this was a news story that I mentioned on Space Bites last week. A story written by Sarah Scholes about the status of Breakthrough Starshot. And this is something that I think those of us in the community had expected was coming for a while now, which was that it had just been kind of quietly shut down. You know, it was expected to give $100 million to researchers to try and develop an interstellar probe mission. And in the end, it only gave about $3.5 million to various people. And it's sad. It's very sad because I think it was one of the most exciting ideas that we had seen in space exploration in a long time. That, you know, there's a lot of really exotic ideas about how you're going to go and travel to other star systems that people have proposed, you know, fusion drives, the Orion, where you're dropping bombs out the back of your spacecraft. But in the end, really, the only two viable ideas for being able to go to another star system are either an antimatter drive, and we don't know how to produce an antimatter at scale, and we don't know how to hold it, and we don't know how to use it in a way that powers your spacecraft. The other viable solution is a light sail or a laser sail, where you don't carry propellant on board your spacecraft. You just fire at it with a laser that accelerates it up to high speed. And that the idea that was brought forth with Breakthrough Starshot was to build these solar sails really small, just a few meters across, and then make the spacecraft itself just a little tiny chip. And that you could send a fleet of these things and they would be able to visit another star system within a human lifetime and be able to send back information. And you had a lot of luminaries who joined the announcement. You had like Seth MacFarlane, you had Stephen Hawking, you had Avi Loeb, you had Mark Zuckerberg. Like, there's a bunch of people involved in this, as well as the funding from a genuine billionaire who was so excited about the idea that he was willing to put down theoretically $100 million of his own money to make this happen. And what it showed with the amount of press that they got was the pent up desire for humanity to do something special, for us to have the moonshot of our generation, to send a spacecraft to another star system, to realize the dream of all of this science fiction that we have been consuming for decades, 100 years. And it's so heartbreaking that it turns out the money wasn't distributed in the way that it was expected, and that nobody told us. You know, it's like you're following a leader across some difficult journey, and the leader just kind of slips off out the back when no one noticed, and you're still walking, and you're like, wait a minute, where are we going? Because the leader's gone. And I think that demonstrated the public enthusiasm for this. And so I think if anybody who is wealthy is watching and listening to this, or, you know, that demand is still out there. And if you want to make a big impact on the sort of harness this enthusiasm across so many layers of society to send a spacecraft to another star system, to give us that first up close glimpse of what it would look like in another star system. When you consider the amount of money that's getting spent by NASA, by ESA, by JAXA, by the Chinese, you know, you're looking at tens of billions of dollars every year to keep various space hardware operating, to build probes, to build a helicopter for Titan, things like that, right? $100 million is actually not very much. That is chump change. That is the price of one small mission for NASA, one small mission for ESA. And yet, the amount of goodwill and public relations that got is incalculable. And imagine if some space agency, some group pulled those funds together, backed by a billionaire who was going to keep writing the checks, and very carefully and very intelligently actually continued the progress. And it might not be a thing that will come together in our lifetime. Like, it's almost certainly a more complicated problem than we are expecting, than science fiction has led us to believe. But just the doing, the putting our minds to this process of trying to pull together the best and the brightest across the entire planet to solve this challenge is worth doing. And it will pay 100-fold back to human society in the engineering that's discovered, in the bonds that are forged, in the new relationships, the new connections, in the things that we discover. And it has this incremental value. So it's not just, if we make it to another star system, then the payoff is there. But the reality is that this technology of using laser sails to explore inside the solar system would completely change the way we explore the solar system. That you could send tiny little solar sails off to every single comet, every single asteroid, every single moon, all of the planets. You could send tens of thousands of these things within the solar system and learn a tremendous amount about and practice. So we have the ways to practice in the near term. All of these technologies have value across our entire society. More powerful lasers, better solar sails, miniaturization of technology. Like, the benefits are there. It's just, and that this is the most viable idea that anybody's ever thought of. And so this is a thing that we should continue to work on. And it sucks. Like, there's this idea where it's kind of like a FOMO, sort of, where when you discover that somebody is doing something that you're excited about, then you sort of go, okay, well, so the problem is being solved. I don't have to think about this anymore, right? Sending humans to Mars. Oh, Elon Musk's got this figured out, then I don't have to do this, right? Or maybe his idea isn't going to work out. And all this time spent waiting for them to accomplish it is time that could have been spent working on it in other ways at the same time. And that it takes many different ideas all at the same time. And so I think my perception was that Breakthrough Starshot became this sort of place where people focused their attention on, that they were the ones that were doing it. And so everybody kind of took a back seat. Like, a lot of people work on really interesting projects and a lot of technologies moving forward, but it really feels like we were waiting for them to carry the torch forward, and they didn't. And so now somebody's got to pick up the torch and start carrying it forward. But for real this time. So yeah, I think that that's the part that's so disappointing. And I think, like, if I was going to do it, I would probably make it much more transparent. I think that, we learned some announcements of various things that had gotten funding, but I think the way you do it is you make the whole process, like, try to get as much crowdfunding as you can from people to be donating, try and bring in grants, getting government projects, and so on and so forth. And then have some website where people can see all of the projects that are working on right now and how they're working out, and they can contact the researchers and they can see where their money is going, and people can come together for town halls and discuss the various pieces and discuss the technological readiness levels, and, turn it into this giant community of enthusiasts and engineers and scientists and people who are funding this, that are moving the whole thing forward, and not just this, a couple of people are working on this. They've probably got it under control. I'm just going to wait for them to solve it. That's not going to work. It's got to be this giant, transparent, collaborative process, in my opinion. I was heartbroken when I read the article, and yet it was just terrific journalism. And hopefully somebody else will pick up the torch, and we will continue on with the incredible dream of sending a probe to another star system to take pictures up close. It's time to shout out our new patrons at the $5 level and above. Geronimo, Tony Roberts, Fan of Matt Ball, Sammy P, James Huffman, Shen, Jeff Azevedo, Gunter Hofer, Zach, and Chris Benton. Join our community at patreon.com/universe today. Brendan Thigpen, what is the latest in anti-gravity? Are we making any real progress? So there is no anti-gravity, and we are not making any real progress. Nobody has come up with any possible way to come up with anti-gravity today. The last hope that we had for anti-gravity was that antimatter would experience anti-gravity. And this was like one theoretical possible way that this could work. Now, you take regular matter, you reverse the charges, you get antimatter. You combine regular matter with antimatter, it explodes, annihilation. And so it was theorized that maybe antimatter would fall up in a gravity field. By no means this was assumed that this was going to be the case, but it's really hard to take one single, say, proton and then drop it in a gravity well and then make sure that it is actually falling down and not falling up. And it wasn't until a year ago or so that scientists were able to perform the experiment with a level of certainty to rule out that antimatter falls up, that antimatter experiences anti-gravity. So antimatter experiences normal gravity just like regular matter, which is what you would expect. And so that as a possible route to get to anti-gravity has been ruled out. So right now, we don't know of any way to make anti-gravity to repel. And, there are thoughts that if you could get your hands on negative matter, negative energy, that you could somehow produce anti-gravity. But for now, it's purely science fiction. Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We call it Q&A Plus. In this week's bonus question, are ion engines the future of space travel? And I'll put a link in the show notes. All right, those were all the questions that we had this week. Thank you, everybody who posted your questions into the YouTube comments, everybody who joined me for the live show. We are doing the live shows every Monday at 5 p.m. somewhere in the world. The time changes, so you have to go and come to the channel and you'll see when the next event is going to be. Now, if you're watching this show within a couple of days of when it came out, the next live show is going to be on October 6th at 5 p.m. Pacific time. So if you want to come join the live show, there should be an event here on the calendar. Now I'm going to show you my new telescope, but first I'd like to thank our patrons. Thanks to Abe Kingston, Andrew M. Gross, Braley Griffin, Brian Bodie, Caradwin, Chuck Hawkins, Commander Baylock, Cy Nielsen, David Veriboff, David Giltonen, David Matz, Evan Pro, Greg Feely, Hudson Moore, James Clark, Jeremy Madden, Jim Burke, Jordan Young, Josh Schultz, Marcel Spitz, Michael Purcell, Monzo, Paul Robach, Renkaidu, Richard Williams, Sean Sargent, Stephen Fowler-Melly, Team 49, Vlad Jiplin, and Wolfgang Klotz, who support us at the Master of the Universe level, and all our patrons. All your support means the universe to us. So as you probably know, a few months ago, I bought my first smart telescope, which is the one behind me right there. That is the C-Star S50. And it was sort of like a relatively inexpensive introduction to doing astronomy. And Vaonis, which was sort of like one of the first developers of smart telescopes, reached out to me a couple of weeks ago and wanted to know if I wanted to get a copy of their new telescope. And I was really resistant because I kind of want to be able to, want to be buying telescopes with my own money. And they said, well, it's got clear plastic, so you can see all of the innards of the telescope. And I said, fine, okay, yes, please. So they sent me a copy of the telescope. And so here it is. So this is the Vaonis Vesper 2. And that's sort of the telescope part there. And what's cool is it's got clear plastics. You can actually see all of the internals of how this thing works. And this is the Vesper 2. The Vesper's been around for a while. They've got a bunch of models. We actually reviewed the first Vaonis, which I'm sure now Chad is going to show you the first pictures that we took of their telescopes. So I do have a special soft spot in my heart for this company. And so just like fair warning, this was a free telescope sent to me by the company. And so that's the disclaimer, which I'm going to now have to make sure that I remind you of. Now, you're probably wondering, how are the pictures? How does it work? And the answer is, I have no idea. I've had clouds for the last week. We've had a drought here on Vancouver Island for 5 months. Clear skies every night. And then I get a new telescope, and that brings the rain. So I'm going to have to wait before I can show you what the pictures are from this telescope. But I got like one morning of partial clearing, and I was able to take a few pictures, and they look great. But then the clouds came in, and then I wasn't able to continue on. So stay tuned for the actual pictures in my review of the telescope. But anyway, it's in my hands now. All right, we'll see you next time.